Hey everyone, welcome back to my another tutorial series. This tutorial series will be about one hidden layer neural network. So in last tutorial series, we were building a simple logistic regression to classify dogs and cats. And now it's time for building a neural network, which will have one hidden layer. And you'll see that there is no big difference in this model or code and comparing with logistic regression which we were implementing. So the structure of our code will be very similar. So at first we'll define a model structure, that data shape, then we'll initialize the model's parameters, and we'll create a loop where we'll do same steps. So we'll implement a forward propagation, compute loss, implement backward propagation to get gradient, and then we'll update parameters and join everything into a single loop. So this will be just like in logistic regression tutorial series, that will build three helper functions where we'll compute three first steps mentioned here, and we'll merge them into a neural network model. Once we'll have our neural network model, we'll train it and we'll try to make up predictions on the same data set of cats and dogs. So at first we should mention that we have to define our model architecture. And here is my tutorial from logistic regression, and here you can see that there was image inputs into one neuron, and where we used a sigmoid function, and it was giving us an output if it's a cat or not a cat. And now we'll use a hidden layer. So I'll open the same code. There is my logistic regression full code, and now we'll use a different architecture. So this will be our input layer. So here might be the same input of cats or whatever you need. Then there will be our hidden layer of neurons, and we can use whatever count we would like to. And then here we'll use tangent function, I must mention, and then everything of it will go to our sigmoid function, same as it was here in our architecture, and it was giving us an output probability. So prediction of cats and dogs. So the same as in previous tutorial, I would like to use same code as before. So I'll open so I'll just copy it and I'll call it a neural network model, just like that. And I now should delete some functions. So I'll leave read image, prepare data, and sigmoid functions, and I'll use same dataset in my tutorial, so I'll leave them. And now I will remove some functions of forward propagation, backward propagation, and predict function. These functions I'll remove, and here's our model. I'll remove also. If we'll need to, for some similarities, we'll copy it later. Now I also would remove this, and now I'll remove also and this. So this is our data preparation step, so we'll leave it here as before. And here is our initialization function, which we'll use in this tutorial. I'll comment this here, and later I will remove it also. So this will be our beginning of code. I just copy it, not to rewrite everything from zero, because this takes time, mine and yours, and we don't need that. So anyway, I'm saving it, and now we might start building a initialization parameters step as we did here. But right now we are building this for not a one input layer. Here we were initializing as weights as zeros and bias all as zeros. there was only one bias. But right now, when there will be a different count of hidden layers and so on, we should do this step a little different. So here I'll just define a new function, and I'll copy it, and here initialize parameters. All right, just like that. And this will be our n from x layer, so this will be our input layer, how many inputs it has. Then will be our hidden layer and our output layer. At first we'll initialize our weights of first layer, bias of first layer, then will be weights of our second layer and bias of our second layer. So here before we were initializing them as zeros, but now we should initialize them as random numbers, very small random numbers, because now if they would be zeros, then or same numbers, there won't be any effect from that, so there will be some very similar results in all hidden layers. So in this case we need to initialize them as different, so we'll multiply as by 001, and here will be our layer. This is our output from first layer and the input into first layer. Keep remember that. Then we'll initialize zeros as our bias. Well, because it doesn't matter, it's only subtracts some value to it. And here will be our layer zeros, because it should be like that. And our second layer will be also very similar, but instead of nx, here will be our nh layer, and this is our input, and here is our output layer, so this will be our ni layer, and bias for our second layer will be ni also. And this is our random numbers between 0 and 1, and we are multiplying it by 0.01 just because we won't have large numbers. We would like to have numbers close to 0 but not 0. So that's it, and now we just write our parameters. And here, as same as before I was doing, I'll write a dictionary, just like weights of 1 equal to weights of 1 and so on. I'll just copy it to make it a little faster. So sorry, it's not getting faster, I think, but anyway, everything will be fine. So here is weight 2, and here is bias and bias 2, just like that. And our function will end with a return of parameters. So as you can see, here we were initializing weights and bias. So here we are doing the same. Instead, we here not initializing a zeros, but zeros goes only to bias, and here is numbers close to 0 and returning all of them. Here we return it as W and B, and here we return all weights and bias as dictionary. That's it. So here I won't use any example because it will take more time to write example and so on, but it doesn't need that. So now, as I didn't mention it, I think, but our hidden layers will take tangent function, and here was a sigmoid function. So I would like to cover a tangent function for shortly, and for this I'll just copy code from my first tutorial, and there was a sigmoid function, and I think I should have this import, but I'll just double check that. I have numpy, plab as I don't have that, and matplotlib as pylib. Okay, it will be fine like that. We'll use them as import, and here we had a sigmoid function. So here we have not a sigmoid function now. Well, at least we can remove this, totally remove, and instead of sigmoid we'll have a tangent h function here, and here will be our numpy tanh function. I think it should be like that, and here where we are computing a sigmoid derivative, will compute a tangent derivative function. So we just remove this. I will not show a function u for now, but later we'll need to use it and I'll show it to you. But right now it's a simple function of 1 minus, sorry, and here is numpy power, again power, and here we are computing our numpy tangent h by x, and it's by 2. Well, yeah, I think that's it. I modified it quite fast because I don't want to waste our time here in this tutorial, and let's build it and we'll see what we have. Okay, here is some kind of problem here, and I forgot to add this. Doesn't matter, and here we don't need that last step. In our right now we are importing our data set, but I'll just comment these steps for now because we won't use them for few tutorials from now. Okay, let's build it again, and of course this, just like that. And as you can see, before we had this kind of function, and it's two functions. Okay, it's okay to me. And before it was from 0 to 1, and tangent, you can see that it goes similar, but it's instead of 0 it goes from -1 to 1, and here it goes from our derivative, it goes from 0 to 1 and from 1 to 0, and here it went, I don't know how much it is 0.25, something like that, maybe more, but it doesn't matter. So what this does, that our weights won't go as much to negative or positive side. So our tanh function, it keeps of weights between -1 and 1. So that's what it does. And then it goes to single sigmoid function where it predicts us the prediction of 1 and 0. So that's it. So in this tutorial part, I tried to fast cover how to initialize the architecture and structure of our one hidden layer neural network. So, and I wrote a fast code of how to initialize our one layer parameters, and of course I'll copy this to my page where I have a text version tutorial, and you won't need this to copy from my video. So anyway, in my tutorial I'll delete this part of code and I'll leave this as commented part. So if you would like to try this by yourself, you should go to my last tutorial where I was writing a code for logistic regression and copy code and play with it a little bit. So that's it for this tutorial. Thank you all for watching. Follow me, follow this tutorial if you would like to learn more about neural networks and deep learning and so on. So I will continue this tutorial. So thank you all for watching. Subscribe, like this video, and see you in our next video where we'll continue to build our code, where I will plan to write a forward propagation function, and maybe if we will have time, cost function. So goodbye for now.